Okay, we're looking at number 16 here. One of the issues we can have is that we don't have both sine or in this problem we have sine and we have cosine. We want to just solve for one of them. We want to solve for either sine or cosine. So let's go ahead and use one of the trigonometric identities and solve for either sine or cosine. So what we're going to do is let's go ahead and use the triangle identity here. Again, I'm looking at my trig bit sheet. So I'm going to use the fact again. Whoops. Right here, triangle identities. I'm going to use the fact that sine squared plus cosine squared equals 1. Or I can say 1 minus sine squared equals cosine squared, or 1 minus cosine squared equals sine squared. So I'm going to use that right now. Let's go ahead and use the identity that sine squared equals 1 minus cosine squared. So sine squared x equals 1 minus sine squared x. Whoops, sorry about that. Keep zooming in and out here. Okay. So again, what I did was I used the trig identity right here. I said from cosine squared to 1 minus sine squared. So now I have just a sine. And now I'm going to try to solve for sine of x. Let's distribute that 3. Okay, let's go ahead and add 3 sine squared x to both sides. So I'm going to add, just like any variable, we can add these things to the same side. Now I have 4 sine squared x equals 3. I'm going to divide by 4. Sine squared x equals 3 over 4. Okay, I'm almost done. Now I have sine x squared. That's another way I can look at it. Sine x quantity squared. So to get rid of a square, I'm going to square root both sides. But when I take the square of a square root, so I'm going to be left with sine x, I have to say plus or minus the square root of 3/4. Okay, let's simplify this radical a little bit, and you're going to see that whenever you have 3/4, that is going to just be the square root of 3 over the square root of 4. Well, the square root of 4 is 2. Now, look at that for 1 second. Man, we have dealt with this quite a bit in the unit circle. We're very happy to see something like that when you have your as your final answer. We like to see something that says that you should be, when you're looking for your answer, it should be something like 1/2, 0, the square root of 2 over 2, the square root of 3 over 2, or 1. Those should be your answers, because those are the convenient answers that you'll see in these kind of problems. If it's something other than those numbers, you can use the inverse sine function to figure out what the number is. But again, what you should be seeing is something, again, that is either 0. So these are answers you should be seeing. You should be seeing 0. You should be seeing something with a 1/2. Again, square root of 2 over 2. Square root of 3 over 2. Again, we're looking at for numbers. So again, this is building the intuition right now. We're looking for numbers, again, where it's just these numbers right here. We're looking for these numbers. Those should be our answers that our final answer should be looking for. And then for tangents, again, you should be looking for something like the square root of 3 over 3, or just a square root of 3 by itself, 1 or 0, something like that. So again, that's why it's very crucial you do a lot of these problems right here. Again, you're looking for something that looks just like these. That is what we would like to see. And as you can see, that is one of our answers. So we have sine x equals plus or minus the square root of 3 over 2. Let's go back and finish this problem now. So either sine x, okay, I'm going to split the plus or minus now. So sine x either equals negative square root of 3 over 2, or sine x equals positive square root of 3 over 2. Okay, now you got to look at that trig bit sheet. Okay, negative square root of 3 over 2 or positive square root of 3 over 2, and that's for sine. We have pi over 3, 2 pi over 3, we have 4 pi over 3, and 5 pi over 3. So we have a lot of different answers here. So for this one, it was negative square root of 3 over 2. So x is either 4 pi over 3 or 5 pi over 3. And then for the square root of 3 over 2, my angles would either be pi over 3 or 2 pi over 3. Okay, and what we can see here, well, not what we can see. Again, this is where you have to remember what is the period of sine x. Period of sine x is 2 pi. Okay, so that means we can take this answer and we could add 2 pi to it, and we would also get the same answer. Here you could add 2 pi to it. Here you could add 2 pi, 2 pi. Okay, so this is going to be a very, very fun answer. X equals 4 pi over 3 plus 2n pi. Okay, again, I have 2 pi and I can multiply it by any integer. Okay, or it could be 5 pi over 3 plus 2n pi. Or it could be pi over 3 plus 2n pi. Or it could be 2 pi over 3 plus 2n pi. There are many possible answers here. So please keep that in mind. So your answers, again, you can see that your answers here will be like in the angles, and they're in radians. They're in radians. We're not using degrees too much anymore, at least in this section. So you can see again, because the period is 2 pi, I can take this number and multiply it by any multiple of 2 pi, and I will get a correct answer.